All right, let's jump right in. Today, I'm going to be playing the role of a senior hiring manager to give you the absolute inside scoop on how to completely ace the most critical RGR. That's retrieval augmented generation, technical interview questions. Whether you're gearing up for a machine learning engineer role or a system architecture position, mastering these specific concepts is exactly what's going to set you apart from the rest of the pack. We've taken 30 of the most common and, frankly, the most challenging questions and synthesized them right here into this single high-impact explainer. So here's our game plan for today. We're going to cover fundamentals and architecture, then move into embeddings and chunking, hit advanced retrieval and re-ranking, tackle prompting and hallucinations, break down evaluation metrics, and finally, we'll wrap up with production and system design. Okay, part 1, fundamentals and architecture. Now, when an interviewer sits down and asks, what exactly is RAG and why do we even need it, a top-tier candidate doesn't just spell out the acronym. No, you really need to explain the why. You've got to point out that LLMs have some major limitations, right? Their knowledge gets outdated, they have absolutely no access to private company data, they're notorious for hallucinating, and honestly, retraining them every time facts change is just incredibly expensive. So RAG swoops in to solve this. It retrieves current, authorized information right at the time of the query, which allows the system to actually provide real citations. It's a total game changer. And to really nail this, you must be able to distinctly walk through the 2 core pipelines. First up is the offline indexing pipeline. This is where you connect to your documents, extract the content, chunk it up, create the embeddings, and store it all. Then you've got the real-time online query pipeline. That's where you receive the user's question, rewrite it, retrieve and re-rank your candidates, build a grounded prompt, and finally generate your validated answer. Seriously, cleanly separating these 2 shows you truly understand how RAG operates in the wild. Moving right along to section 2, embeddings, chunking, and similarity. So a huge question you'll get is about how vector similarity search actually works. The crucial thing to get across here is that vector search compares a query embedding against document embeddings using mathematical distance. You'll definitely want to drop terms like cosine similarity, dot product, or Euclidean distance. Cosine similarity, for instance, measures the angle between 2 vectors, so the higher the similarity, the closer the semantic meaning. And hey, here's a massive pro tip for you. When they ask how you choose your embedding model, please do not say you just picked the top one from some public leaderboard. You need to tell them you tested against your actual domain, your specific languages, and your unique document types using hard metrics like recall and NDCG. Now, interviewers absolutely love asking about chunking because, honestly, it's a massive design decision. You've got to make it clear that you don't assume one size fits all. It's a balancing act. You have to balance the chunk size to avoid feeding the LLM too much irrelevant noise, while also using overlap to prevent a critical fact from being separated from its context. Like a policy rule getting completely split from its exception. High-level candidates will bring up structure-aware chunking based on headings, and they'll prove their setup by tuning it against actual retrieval metrics. All right, section 3, advanced retrieval and re-ranking. At this stage, you need to cleanly contrast sparse and dense retrieval. Sparse retrieval, like BM25, is your exact keyword matcher. It's absolutely perfect for things like product codes or specific legal citations. Dense retrieval, on the other hand, uses those semantic embeddings we just talked about, which makes it amazing for paraphrased questions and natural language. The absolute perfect interview answer here points out that production systems almost always combine the 2. Why? Because dense retrieval misses exact IDs, and sparse retrieval totally misses paraphrased intent. Which leads us to reciprocal rank fusion, or RRF. This is your silver bullet answer for how you merge those sparse and dense results together in a hybrid retrieval system. See, BM25 scores and vector similarity scores use completely different mathematical scales, so you can't just add them up. It doesn't work. RRF steps in to provide a stable, rank-based mathematical formula. This ensures that a document ranking highly in both lists gets pushed right to the very top where it belongs. Okay, so once you've retrieved your candidates, you've got to re-rank them. Be ready to explain that a BioEncoder casts a really wide, fast net for first-stage recall across millions of documents. But because it processes the query and the documents independently, it's not perfectly precise. And that's exactly where you introduce the cross-encoder. It acts as this powerful, albeit slower, re-ranker for just your top 50 or so candidates. It processes the query and the document together, ensuring your final context precision is absolutely perfect before you ever send it over to the LLM. On to section 4, prompting and hallucination mitigation. Creating the prompt is way more than just passing a block of text. A top-tier answer here details separating your system instructions from the retrieved evidence. You've also got to provide stable source IDs for that evidence. You want to explicitly command the model to cite the supporting source for any material claims it makes. And honestly, most importantly, you have to command it to abstain or explain conflicting sources, rather than just silently guessing and making something up. So when the hiring manager asks how to reduce hallucinations, whatever you do, don't just say better prompting. You've got to break it down as a complete end-to-end system problem across 3 distinct layers. First, you improve retrieval with hybrid search and re-ranking so the model gets better facts to begin with. Second, you improve the generation phase with explicit grounding and low randomness. And third, you add verification layers to actually validate citation IDs and double-check dates and numbers before the user ever even sees the output. All right, Section 5, Evaluation Metrics and Testing. I cannot stress this enough. I highly recommend you just flat out memorize this evaluation breakdown. Connecting a specific metric to its actual real-world business use case shows immense practical maturity. For instance, use recall at K when missing evidence is your absolute primary risk. Use mean reciprocal rank, or MRR, when the very first correct result is what matters most to the user. And you deploy NDCG when you need to measure ranking quality across several passages that all have totally different degrees of relevance. You also absolutely must distinguish between correctness and faithfulness. Honestly, this trips up a lot of candidates. Correctness asks if the answer is factually true out in the real world. Faithfulness, though, asks if the answer was derived strictly from the retrieved evidence. Make sure to point out to your interviewer that an LLM can actually give a correct answer based on its pre-training that is completely unfaithful to the provided document. Or conversely, it can give a faithful answer that is factually incorrect simply because the retrieved document was outdated. And when they ask how you diagnose a failing system, drop the Oracle context test on them. This perfectly shows how you scientifically isolate a bug. Basically, by manually feeding the LLM the known perfect passage, that's the Oracle context, you can see if it generates the right answer. If it does, great. Your generation prompt is fine, and you know the bug is upstream in your retrieval pipeline. But if it still fails, well then the problem is either your prompt or the LLM itself. Finally, Section 6. Production, security, and system design. Listen, a massive red flag for interviewers is if a candidate suggests filtering document permissions after retrieval. You must emphasize deterministic authorization. That means applying access control lists before retrieval even happens. Never, ever let the LLM decide if a user is allowed to see a document. Furthermore, always treat retrieved documents as potential prompt injection threats. They are fundamentally untrusted data. Now, towards the end of the interview, they might throw a curveball and ask about cutting-edge concepts. Show them you're up to date by comparing Agentic RAG, where the LLM dynamically plans multiple retrieval steps, with GraphRAG, which uses entity relationships to connect information across documents. But here's the critical part. State very clearly that you only deploy these high-latency, high-cost architectures when hard evaluation proves that a simpler retrieval pipeline has failed. And then, you get the ultimate capstone question. Walk me through a RAG system you designed from scratch. This is where you bring it all together. Tell them a story. Explain exactly how you started with document ingestion, how you chose structure-aware chunking, implemented a hybrid sparse and dense retrieval system, added a cross-encoder re-ranker, and then measured the whole thing using NDCG for retrieval and faithfulness scores for generation. I really recommend concluding your system design answer with this exact philosophy. Saying this proves you have actually been in the trenches. It shows you understand that rigorous data engineering, excellent chunking, and precise metadata filtering will beat just throwing a bigger, more expensive LLM at the problem every single time. So I'm going to leave you with the thought to ponder as you prepare for your interviews. Are advanced, highly complex architectures like Agentic and GraphRAG always the mandatory future? Or is mastering a perfectly tuned, simple retrieval pipeline still the absolute smartest engineering choice for most businesses? Master the fundamentals we went over today first, and you will absolutely crush your RAG technical interview. Thanks so much for joining this explainer, and best of luck out there.